First we'll look at what an arithmetic sequence is. If we have a sequence that starts, for example, 7, 10, 13, 16, 19, we soon start realising that there's a common difference of 3. We add 3 each time to get the next term in the sequence. If we did this enough times, we could get the 10th term. In this case it would be 34. Let's have a look at another case. We'll start with the first term of 8, second term of 2, third term of -4. We now know that there's going to be a common difference of -6. So if we subtract 6, we'll get -10, -16, and if we keep on going, we'll get to the 10th term, -46. If we have a look at the general case, we'll start with the first term of a. We add the common difference, which we'll call d. So we have a plus d. To get the third term, we add d again. So we have a plus 2d, a plus 3d, a plus 4d. Now if we have a look at what's happening here, notice that we add d for the second term, we add 2d for the third term, we add 3d for the fourth term, and so on. And so we can deduce from this that for the nth term, for the general term, we end up with a plus n minus 1d. This is the general case for the nth term of an arithmetic sequence. It's an important general result and one that you should commit to memory. We've just looked at sequences. If we now sum those sequences, we end up with a series. So if we want to add them, we'll add the terms of the sequences together, and so we'll now end up with a series, the summation of it. If we want to find what that sum is, let's have a look at what we could do. Well, if we pair these off, we could pair the first term, this 7, with the 34. The next pair we'd make is the second term 10 with the ninth term. The ninth term here would be 31. And so on. We'll realise now that our pairs, our 7 add 34 is 41, our 10 add 31 is 41. So all of our pairs will add up to 41. There are 10 of our terms altogether, and so we have 5 pairs, and so we'll do 5 lots of 41, and we end up with our sum of the first 10 terms of this being 205. We'll have a look at this in the general case again. So we start with a, we add a plus d, we add a plus 2d, we carry on, and we add the final term, a plus n minus 1d. Recognising then that we can pair these up, we pair the first and the last term, for example. So we have a plus n minus 1d, so in other words we have 2a plus n minus 1d. That's what each pair is. And if we have n terms, we have half of n pairs, and therefore we end up with our sum of the first n terms being n over 2, half the number of terms, 2a plus n minus 1d. Again, this is such an important result that it should be committed to memory.